Clustering algorithm belongs to the realm of unsupervised machine learning, where the goal is to uncover hidden patterns and structures within dataset without explicit guidance from labeled examples. In essence, clustering algorithms autonomously partition data points into groups or clusters based on their intrinsic similarities. K-means clustering is a cornerstone technique in the field of unsupervised machine learning. Imagine you have a vast dataset filled with information waiting to be organized and understood. K-means clustering acts as your guide, helping you sift through the data and uncover meaningful patterns and relationships. The K-means algorithm is an algorithm to cluster an object based on attribute into key partitions, where k less than n. It is similar to an expectation maximization algorithm for mixtures of Gaussians in the day. Both attempt to find the centers of natural clusters in the data. It assumes that the object attributes form a vector space. Simply speaking, the k-means clustering is an algorithm to classify or to group the objects based on attributes features into k number of groups. K is a positive integer number. The grouping is done by minimizing the sum of squares of distance between the data and corresponding clustered centroids. This diagram represents the flowchart on how the k-means clustering algorithm works. From each initialization, it will set the number of clusters k. Then it will process the centroids and compute the distance object to centroids and group them based on the minimum distance. Now, if the number object is negatively moved, it will repeat the process from centroid, then distance object to centroid and grouping based on minimum distance. And the number object move positive, then the algorithm will end. Let's see the example dataset in the figure, where y and x-axis represent two different features, and we want to identify cluster in this dataset. Now, when the dataset is given to you, you don't have information on the target variable, so you don't know what you are looking for. All you want to do is to identify some structure. By this visual examination, it represents two clusters, and k-means help you to identify these clusters. Key in k-means is a free parameter. Before you start the algorithm, you have to tell the algorithm what is the value of key that you are looking for. In our example, we set that the key value is equal to 2. Now, the first step is to identify two random points which are considered the center of two clusters. We call them centroids. The next step is to identify the distance to each data points from these centroids. In our given example, this data point's distance is near to this red cluster and it is considered as red cluster. In the right side, this data point is near to this green cluster and it is considered as green clusters. We will going to start with the key centroid by putting them at a random place, and the example is key is equal to 2. The second step, compute distance of every point from centroid and cluster them accordingly. Third step, adjust centroid so that they become center of gravity for a given cluster. Fourth, again, recluster every point based on their distance with centroids. Fifth step, again, adjust centroids. And sixth step, recompute clusters and repeat this till the data points stop changing clusters. As a result, this is my final clusters. Now, how to determine correct number of clusters? In our given dataset, we set that the number of clusters is equal to 2. Some people may interpret it in different way. Some of them will either interpret it as 6 clusters or 2, 4, 3, 5 clusters. Now, your job is to identify what is the best number of clusters. And we're going to do that with the use of elbow method. The way that matter work is to start of some key. Let's start with key is equal to 2. And we try to compute sum of square errors. What it means is each of the clusters, you try to compute the distance of usual data points from the centroid. You square it up and sum of it up so for these clusters. Sum of the squared error 1. Similarly, with the second cluster, we'll get error number 2. You do that for all clusters and then you get the total sum of all errors. The computed SSE for key is equal to 2. You repeat the same process for key is equal to 3, 4, and so on. Once you have that number, draw a plot like this. Here, I have key going from 1 to 11, and on the y-axis, sum of square errors. You realize that as you increase the number of clusters, it will decrease the errors. At some point, you can consider that all your data points as one cluster, where sum of square error become almost zero. Let's assume only 11 data points at 11 where key the error becomes 0. The general guideline is to find out an elbow. So the elbow in this chart, this point is look like an elbow. So here is a good cluster number. A good key number will be number 4. K-means is an interactive algorithm that aims to minimize the within cluster variance, or the sum of squared distance between each data points and each clustered centroid. While k-mean is relatively simple and efficient, it has some limitations, such as sensitivity to the initial centroid position and its tendency to cover to local optima. Therefore, it is common practice to run algorithm multiple times with different initialization and those the clustering with the lowest within cluster variance. Overall, k-means clustering is widely used in various applications such as image segmentation, document clustering, and customer segmentation due to its simplicity, efficiency, and effectiveness in many scenarios.